All right, so finally I get to create this video. So I promised this for a while. This is a video for the contributors that want to hack code inside of the infrastructure to add features, add capabilities, add their own ideas, change things. And so let's jump right in. All right, so I showed you guys this picture before, right? This is the, let's go here. So this is the overarching view of the infrastructure. The green is essentially the code base. But what I'm gonna zoom in on is the compiler. So you can see, like, how do you get into understand the architecture and the code base of the compiler, and then also the runtime library a little bit. I'm gonna talk a little bit about the plugin interface if you wanted to see how you can write your own plugins. I'll just touch on that a bit, but I really wanna make this video for the folks who wanna kinda have their first view of this code base and where they would make changes and how things work. So I'm going to pretend I'm you. I'm doing this a bit off the cuff, right? It's not practice or anything. It's a little ad hoc. But my plan is to pretend I'm you just coming to the code base for the first time. So the first thing you want to do is, here we go. You want to go to the Jaseci repo. This is the repo here. And the first thing you want to do is start repo. The best way to support open source projects is to star and mention and point to the ones that you think are cool. So I think this is cool. I think it's worth a star. So you do that first, and then you just get this is how I do it, right? There's many ways you could do this, but you just copy to your clipboard the repo. I'm gonna make a directory, mkdir, for video stuff, video coding, and then let's go there, and then I'll git clone, and then I'll paste the repo. All right, so this will bring down the entire repo locally on your machine. Of course, I strongly recommend you use Windows subsystem for Linux if you're using Windows. Otherwise, use Linux, like Ubuntu is great. Otherwise, use Mac. Mac seems to be building good products again. I don't know how it seems like they're not DOA. Okay, so Mac is cool still. Okay, let's see. Hopefully that stays longer. So we just checked it out, right? First thing I do is I start my code from the location, and then the window pops up here, and then you'll see something that says, do you trust the authors? And of course, we're very trustworthy. All right, so this is what you'll see. Let me make it a little bigger so you guys can see. This is what I'm kind of used to. I'm not going to use Copilot. No need. It's actually, sometimes it slows me down. All right. So get the terminal up, and now we're good to go. So we're in the code base. So the first thing you want to do is create a Python environment. And I'm kind of figuring this out as I go. So let's do Python 3. Let's make sure that's in here. Okay. So Python 3, -venv, and then the directory. Let's call it fresh. Okay, yeah, that's a good name for an environment. So let's activate it. Fresh bin activate. Okay, so now we're in fresh. So now we can pip install stuff. So the first thing I would do is pip install -e just so that you can access any changes you make. So pip install -e the Jack folder, right? So Jack folder is essentially Jack Lang. That was quick. Okay. And then pip install -g Jack Cloud. And this is primarily because I like to test both together. The reason why we have this mono repo, and if you notice in this mono repo, we have Jack ByLLM, Jack Cloud, and Jack Streamlit. That corresponds, of course, to the code I mentioned here. So we've got this main box is Jack Lang. That's the pipey package for Jack Lang is the main box. And then the ByLLM is Jack ByLLM, Jack Cloud, and Jack Streamlit. Yeah, you'll notice we don't talk about Jack SpliceOrc. It's not really maintained. We might actually move that into Jack Cloud because it's kind of a piece of Jack Cloud. It's just there for now. It'll probably be gone by the time you see this video, or refactored into a new subdirectory. Anyway, so everything's installed in our environment. We got to also pip install. Oh, cheat code. Here's a cheat code. So if you want to kind of see how CI/CD works in GitHub, this is a good way to know what you need to install. You can always go to the, what was it called? Something Jaseci. Test Jaseci YAML. So here you can kind of see like how it's run. in the CI/CD, well, in the automated testing in GitHub. And so, you know, really for the parts we're going to talk about today, just Jack and Jack Cloud is sufficient, but you can install all this stuff and then you could run all of the tests, but you're going to need to pip install, because I created a new environment. So you'll need to pip install pytest and then pytest xdist, and xdist lets you use all the cores of your machine to run parallel tests. So that's good. We're also going to need async IO. So I should have put async IO. Let's just add that so that we can like run tests, right? So the first thing you want to do really is run the test. Also, you might as well pip install pre-commit, because if you're going to commit anything, you're going to want to run pre-commit and then pip and then pre-commit install. And then, okay, it's installed. Okay, I guess it's loading all the cache stuff off of my system. That's fast. That's fast. All right, so now we're set up. So now we want to make sure pytest is working. So let's pytest -s jack -n30. I got 32 cores on this machine, so I like to use all the cores for the test. There's one test here that non-deterministically, all the tests pass when you run the test sequentially, but in parallel, there's one test that sometimes fails because it's that one. It's that one that sometimes fails. Let me make sure you guys can see all this that I'm showing. But it sometimes fails. So you see the failed test. Wonderful. But let's make this a little bit smaller maybe. Let's make this a little bit bigger here. So the one test fails because it's an asynchronous concurrency test. And so being that I have so many threads running, that one usually I usually ignore it if that particular one fails. And so, this one, actually, this is a different one that fails because I didn't pip install by LLM. Might as well install that one too. Pip install -e jack by LLM, just so that that library is also present. So some of the tests will touch these other repos, and this is deliberate at the moment. Eventually, these may become separate repos because the mono repo was only for being able to cross test across the closely coupled plugins. You know, being that it's an early project, these plugins are still kind of being co-designed with the main infrastructure. So if we run that again, this should all pass. But except for that one concurrent thing, potentially non-deterministically. Okay, cool. But anyway, tests pass. So now let's look at the code base. Let's see. Maybe you could. Let me just show you how to run something super quick, just to test that you can run it on your command line. That ends up being useful. So let's go to circle.jack. So this is just one of the. This is kind of my common, Jack file that I'll usually use as my, just one of the common test cases that I'll run things with. We could actually do this in another window while this is running. So I can split the screen, and then I can do Jack. And then you just do circle.jack, and then you run it, and we didn't source activate our environment .fresh bin activate. So now Jack should be there, and we're good. So okay, so that's good. So that all works. So basically you're set up, right? Everything's set up. You can run tests, you can do your thing, refactor, add capabilities, etc. What I'm going to show you first is I'm going to show you the main critical path of doing anything in the compiler. So of course you've got a file, and I'll just show it to you kind of by clicking through here, but you have a file in CLI called cli.py. Now this file, of course, is where we implement the command line interface, right? So if you do jack -h, which will give you the help menu, you'll see there's all this like help stuff. And basically to run Jack, you can run Jack with a bunch of optional flags for stuff, and then a command, and then your file, right? So when I do just Jack, the circle.jack, that's running run. Actually, it's the same as Jack run command. So it defaults to the run command if you don't offer anything, but there's all kinds of commands. And some of the commands that are super useful if you're going to tweak with like the compiler, or you're going to tweak with anything, is we have all these tool IR, like AST, and this will print to the screen the abstract syntax tree of whatever file you pass. You can also do this for the symbol table. I think it's symtab. So Jack tool IR symtab, and then you can kind of see like the symbol table that is generated okay, it's sim, not sim tab. And it's at invalid key. So we try to do a good job with this help menu so you can remember all the commands. So you can try to push that to kind of see how far you can push it. So if I do sim, then we should see the symbol table in this kind of output. And of course, at the bottom of the table, you see all the built-ins. But here you'll see like your module and the various symbols and abilities and so forth and public. And so you'll see some things that are kind of nicely Jack-tastic. Anyway, so this is, there's a bunch of these, right? Now, if you want to see where those are implemented, first off, I will show that in this CLI, right, you can go to tool. So tool, and of course I use the various kind of introspection features to automatically generate that command line interface. We don't use anything like Click, which is really nice, actually. Click is a very beautiful library. This one's just done from scratch. A previous version used Click, but then you end up wanting to vendor it, and we don't want any external dependencies and all that stuff. So we were trying to keep the dependencies low in the project. So if you go to the pyproject.toml for Jack, you'll see, oh, it's not highlighted. I don't have the plugin that highlights it. It's so much better if you highlight it. I'll do that some other time. But you'll see there's like no dependencies. It just depends on 3.11 or higher. These are what was been vendored. I don't even know if these are still vendored. Some of these I took out, but things like Pluggy was vendored, and PyGLS, this is for the language server. There's a part of my picture I didn't include that is actually in here. It's just a small detail, but there's a language server provider. There's an LSP kind of attachment to the compiler, actually. That's also in this code base. So it really is kind of, this would be a better picture. This plus LSP, Jack LSP. So if you don't know what an LSP is, just ChatGPT it or something. It's a language server provider. So it actually is how we, it builds in its support for the tooling. So VS Code can do like type checking and stuff. And remember, that's a work in progress, but it's actually a phenomenal piece of work. Anyway, okay. So that's some details just to get oriented, right? So, okay, good. So we talked about some of these things. So you can see the Py project, blah, blah, blah. Oh, the CLI, I was showing you the tool. So tool, if you look at where we keep all of the tools, and these are tools for debugging purposes and just like user friendliness purposes, there's a file called lang tools here. And then there's this AST tool. But if you noticed after I said like tool IR, it's like SEM or AST or all of those. Like that help comes from here, and you can see the code for how it's producing those outputs or where in the code base those outputs are coming from. So you can actually add new tools to this. So if you were to say work on generating some kind of new kind of IR, you can actually add a method here that would be, not symbol table, not AST, but whatever else you might want to output. Currently, it supports the PyAST and all kinds of stuff. The docIR, the Python version. There's also some cool tools like Jack to Py. So you can do Jack to Py of, say, circle.jack. And this is going to convert circle.jack into pure Python. And if you remember from any of the previous videos, there is almost a library mode pure Python equivalent to every Jack module, right? And so you can run some of these tools. You'll see all of those in CLI.py. Now, let's get into the really guts of this. Let's go to run. So I'm going to kind of show you from the perspective of like what's running. What am I doing? Run. So if you go to run here, you see you can pass the file name, etc., the session file, blah, blah, blah. We'll not have to get into all that, but essentially what's happening is there's a Jack import, right? And then the Jack import, because whenever you run a Python anything, you're importing it, right, into sys.modules, detail, etc. But if you go down this journey and you go down the Jack import, and you don't need to go down this journey, I'm just trying to get you to the file in a way that is the key file that's the starting point for where you look at, say, how the compiler is organized. You go into this import stuff. You can kind of ignore this, but really you'll get to this get bytecode, and then you're in program.py. So there's CLI.py. That's useful just to understand the user interface for the command line. Then there's program.py, and this is really where like the start of the magic happens. So this is an important module to look at. Now, if you look at the directory structures here, inside of jacklang, you'll see there's the compiler, there's the CLI, there's the compiler, there's langserve, and then there's runtime lib. So the compiler is in the compiler directory, and then the runtime is in the runtime lib directory. That's the runtime library. And then langserve is the language server. So you don't have to worry about that right now. That's just for VS Code or to drive your IDE, Neo Vim, whatever, to get your semantic tokens, et cetera, et cetera. So it's just for tooling for developers. But compiler and runtime lib are the key places to pay attention to. Now in compiler, there's this program.py, and that's this file. So let's look at this file. This file is really where all the compiler analyses start. So I'll just point it out from top to bottom, right? Not in any other kind of order. I'm sure I'll probably do a better video one day once I can really prep for like how to teach this, but I'm just giving you a walkthrough. These are all the passes. They come from the compiler passes main. These are passes that are brought in. There's also these tooling passes. So you have the formatter, this is kind of an internal preamble to formatter. And then docir is actually an intermediate representation for formatting. So that's primarily what these tool passes are. But you have your main passes, which are just the real analyses or phases of the code organization that happens. And then we have these pass schedules. Now these are going to be consumed later in the program compile functions. These are consumed as pass schedules. So this is just to generate intermediate representation, a schedule for that. Then you've got the Codegen. So this is if you want to generate bytecode, all the way up to the bytecode gen pass, etc. Right? The AST gen pass will actually generate a pure Python AST of your Jack program. And actually, uncompiling that AST is how we do our Jack to Py conversion, right? So this is the key file. Program.py is the key file that gets you to see how this thing is organized, right? Now, one of the things so you have compile here. And if compile runs compile schedules. So if there's a type check involved, it'll run so first, a compile will take flags in to kind of configure how you want to compile. Very minimal, simple, no code gen, okay, or type check on, whatever. So this pass will run this IR gen schedule, and then if there's type check, then it'll type check it by running the type check schedule. If there's no cgen, I see they have a flag here for the pre-Dynamo stuff. This is actually from our most recent paper. So this actually makes PyTorch 2 models faster than Python runs it, which is crazy. Anyway, so that's in there now. So, and then you run the schedule on the Codegen, right? And so, yeah, anyway, so this is kind of the compiler pass as it responds to these schedules. So I'll show that for now. You can always play with that. You can print stuff out. You can tweak stuff just to like get some debug. These are like formatters and stuff. We also have this build, which essentially just uses the type checking, right? So this build will type check first. This is also a preamble to the language server provider. But long story short is here's your passes, right? Now, let's go to a simple pass. Let's see. So the passes are tree walkers. They walk the tree. So let's use a different pass, right? So you can actually have a pass that touches every node in the tree. So maybe a good pass for that. So you can kind of just see that it's a tree walker. PyAST build pass. This touches every node in the AST. It has a bunch of like base, but this is load. Let's do the gen. Where's the gen pass? It's in the schedules. PyAST gen pass. Here we go. So this one touches everything. Like it has enter and exit of every AST node. So one important thing to observe about our IR is we do something called uni-IR. We create a uni-IR. So the uni-IR is simultaneously an AST, a symbol table, and a control flow graph done at the higher level of intermediate representation. So it corresponds to this idea, code property graphs paper. There's a beautiful paper. Oh man, I don't even know if I'll be able to find it off the cuff. Here we go. I think this is it. Let's get the PDF version, which looks better. Yeah, I think this was the paper. Here's the PDF. Was this it? Oh, this is not the exact paper, but there's a beautiful paper that shows code property graphs beautifully. It's a security paper. Oh, why can't I find it? I should keep this on hand. Was it a Usenix security publication? Come on, give me the actual paper. Here we go. I think this is it. Is this open access? Because I'm home right now. Yes, it is. Is this it? Yeah. This is it. Okay, I found the paper. Good. So this is a beautiful paper that talks about code property graphs. So this is a trend in code analyzers where you can have these homogenized views of your intermediate representation using a single representation. And this paper actually eloquently articulates the motivation behind such a thing, which is when you have richer information combined in one representation, new kinds of traversals of that IR and optimizations and analyses become easier to articulate, and new optimizations can emerge from having these homogenized. So here they have 3 different representations, and they show you how they unify that into one beautiful intermediate representation. So we actually take this approach in the Jack compiler. And so the core place that you see that is in, oh, why did that go away? Hold on. Oh, it didn't go away for you, but it went away for me. And I'm bringing it back, and now it's back. Sorry, a little snafu. Okay, so the key place you'll see that is kind of all over the place. But in program.py, if you wanted to just go to definitions to find it, it's this uni tree, right? So this uni tree has tons of nodes. You know, one thing about, and we solved this in Jack actually, but one thing about this darn Python is it's very hard to read code when you have to inline the text, the bodies of all your methods into the same file. But here's a solution. So you have uni nodes, you've got symbol, uniscope nodes, AST nodes. So these are all derivative of uni nodes, and these are all the node types in the uni IR. So this includes AST sounding nodes, but it also includes like a special node that represents a symbol table. And that's the uniscope node. Where is that? Uniscope node. So if we go to uniscope node, you'll see this node has a bunch of interesting methods where you can do lookups and symbol tables and so forth and manage your symbol tables in this representation. So this is what the AST, you could think of this as an AST. Sometimes we just call it an AST because it's like, it's an AST, but then there's layered on top of that AST are other like data structures and representations of the same source file. So that's the unitree node. This is how you get access to all of the nodes of a program. So, okay, so that's like the crux of the compiler. So if you wanted to add something, like you wanted to add a pass, I don't have time today, or I haven't prepped like a demo of me adding a pass in real time. But if you wanted to add a pass, you can take one of these passes, duplicate it. A good one like the def use pass, right? So this pass, and you know, I always want to kind of caveat thing. I want to include in my discussion the roadmap of stuff, but that'll be too much detail, because we're actually going to do some things to remove this pass and then bring it into the type checking system more properly. So there's re-architecture that's going to be happening on this one. But this is a great pass maybe to kind of tinker with and play with adding a pass and adapting, you know, the data structure of your representation. So you can just essentially cut and paste this pass, call it something else, and then do something different in the traversal, and then stitch it into a schedule, maybe have it print something to the screen, stitch it into the schedule, and then you can kind of see your pass runs in the schedule. So program.py, the various passes is how you can modify things. The code, the core, the most, so Codegen is transpiler inspired, right? Because we have this strict requirement that Jack supersets Python in a semantically rich way and targets legit Python bytecode. We'll actually generate we'll actually transpile the Jack AST into a Python AST with callouts into the runtime library. And so this is the pass that does that, right? So you'll see we're entering various nodes and we're rendering proper Python nodes to construct that Python AST. And so you can kind of look at this to see how that Codegen is happening at this level. You can also add passes at the bytecode level because we do have the bytecode gen pass. It's very simple right now. It literally just leverages Python's compiler to compile the AST. However, you have control over that data structure, right? So the bytecode is essentially this object, which is in bytes, but you can disassemble this trivially and then do anything to reassemble it and then append new bytecode to this structure, and that'll be the bytecode that runs when you run a Jack program. Another important thing to observe too, and I should mention this here, is this Jack CLI can run pure Python itself. So it's designed to run both Jack programs and Python programs. So if you wanted to add compiler capabilities based on that UniIR to Python, you can do that. And so you can see that here in run. If it ends with Jack or Py, it will go into that import system, but it'll come out of that import system in program.py on this get bytecode. And if you look at this get bytecode, if the bytecode is not in sys modules or if it's not available, right? This is the Py bytecode that's generated. If it's not available or it hasn't been compiled yet, it'll call compile with the full target. And this compile will, where I'm trying to find the part where we parse the string and it has the file path, and then we check to see if it's Python. And if it's Python, we'll do this PyAST build pass. So this will actually take in as input a Python file and its AST. We actually use Python's parse on the file to produce a Python AST, and then this pass will turn your Python AST into UniIR, and then it'll go through the compiler stack. So anything you do to this compiler stack will be able to be run on pure Python programs. And so that's how we actually achieved this GraphMend paper, where we actually make PyTorch 2 models faster with you just have to run it through this compiler, right? So here's the GraphMend paper that you guys can also look at just to get some inspiration as to what's possible, that you can work on pure Python, compiler techniques for pure Python, because you have control over the entire IR stack all the way through and beyond bytecode. And then, if you've done any advanced Python coding, you'll know that Python makes it very easy to access PyTorch infrastructure, compilation infrastructure, Jack's Python infrastructure. You can really interact with any of the different kinds of systems that would be on the back end and implement solutions through those systems as well, right? So, okay, that's a little bit about the compiler. And I think a good way to get started is, just play with the passes and look at how the passes are transforming both UniIR and how you're generating bytecode and codegenning the AST. You can print the PyAST using the same tool on any Jack file or Python file. So in this tool, if I was to say Jack tool PyAST, I think is the command. It's not PyAST. AST PyAST is not found. Oh, I think it's let me find what the tool is called. Lang tools. And the Lang tool is, where is it? So there's it's PyAST. Jack tool. Oh, IR PyAST. PyAST. I think it's IR PyAST. Okay, so this is the Python AST of the Jack file. So because this is at the point in the compilation where you have pure Python ASTs, and you can see what that AST looks like on that output. So you can play with all these things, tinker with it. There's incredible flexibility in terms of what you can change, what ideas you can try. You can apply it to both Python programs that the compiler will turn Python programs into UniIR, and you can try it on Jack programs, it'll turn that into UniIR, and you have control over the entire compilation stack through and beyond bytecode, because you can continue to rewrite that bytecode with passes that come after the bytecode gen pass. So it's very, very nimble and flexible in that respect. Okay, that's the compiler. Runtime library. What am I going to show you? I'm just going to show you one thing right now. So when you look at the PyASD gen pass, one thing you might observe is there are these calls to, what's a good one? What's a good one? What do we actually call? Oh, I know. Let's do visit. Let's do visit, which is a fancy exit visit statement. So you'll see this jack lib obj. So we render a call to jack lib obj visit. Well, these are the hooks, right? And I think I got to show you guys this in more detail. So let me just jack tool IR. Let's just do jack to pi of circle.jack, and I'll put it in a file called circle.py. Circle.py. So we're gonna put that in circle.py, and then I'm gonna open it. Okay, code circle.py. Okay, I trust you. Whatever. So this is circle.py, right? So if you look at the pure Python version of circle.jack, you know, what you'll notice is it's injecting. Well, that's interesting. We have some keywords in here. Why is it injecting the sum? Circle.py. Do we have a sum? Oh, we have a JL sum. Oh, I guess it just generates that. Okay, there's changes that are coming in. I have the okay. So the byLLM plugin has actually adapted our compiler and is actually putting byLLM stuff in it. So, but this is benign, right? This is the sum keyword, but it doesn't have any this wouldn't have any implications on execution. So if you look at the code it's generating, you'll see there are these like library calls, right? That's sprinkled around it with jack tests and circled up. So this one doesn't have as many like library calls that but you've observed these library calls. So you have this stuff like JL jack tests and JL sem and JL whatever, right? So that's coming from this jack machine interface, this underscore JL. That's where the plugin interface lives. So everything inside of this class, all the methods in this class is the plugin interface. So if you go to machine.py, you'll find, and this is the one that is in Jack proper, you'll see like refs. Let me find a good one. See, the circle.py doesn't have all the juicy ones. Let's do something a little bit more Jacktastic. Okay, let's do simple walk. Simple walk has more Jack stuff that you might want to override in a plugin. So I think this is a better example for showing you linking the Python that's generated in that transpilation loop to the interface where you can edit your own plugins, right? So let's just do this again. We'll jack to pi, and we'll use simple walk, and then we'll put that into simpwalk.py in. I like to put it in the home directory so I don't accidentally commit stuff that I might, like junk files, I don't want to commit it by accident because I do that all the time. Anyway, so let's code that simple walk. And then if we look at simple walk, you'll see that there's a lot more library stuff that's generated. So we have like walkers, and you have this entry here, and you have this visit, and you have disengage, and that corresponds to these keywords, right? So, when we say, we target, Python, this is what we mean. We end up rendering Python with callouts into the runtime library. Now, all of these functions are plugin interfaces through pluggy, right? So let's look at the file that specifies all of it. It's all in one file, and it's called machine.py. And so if we look for JL visit, it's calling this particular interface, which is looking for a walker, which is self, and this is a walker. And then this is the expressions, the legal expressions. And then this implements visit. Now this is a pluggy interface. This automatically becomes a pluggy interface that you can leverage the pluggy to rewrite. And so I'll show you in Jack Cloud, like an example of these plugin interfaces being rewritten with its own functionality. So if you go to, I think it's jaseci.py in Jack Cloud. Here we go. So this is this is in the Jack Cloud directory. You can see that over here. And allow root, disallow root. These are actually permissions granting. These are actually get edges. So these are actually overriding the behavior of some of the abstractions that's introduced in Jack, right? And so the design principle of this, so the TLDR is machine.py shows you all of the potential calls into the runtime library that are possible when you implement Jack code. And by replacing those functions by implementing your own plugins, and you could reference pluggy. It's the same process as pluggy on these endpoints. I'll just show you pluggy. Here's pluggy. PyTest uses pluggy, by the way, too. This is pluggy. So this will teach you how to build a plugin. So it's the same kind of semantics of plugin, and we have example plugins you can look at to see how they were implemented. But machine.py has all of it in one file that you can override. That's if you want to build plugins. So this is it for the plugins. This is going to take way too long to like go deep on like what all of these interfaces do and what the semantics are. But when you learn Jack, you will learn these semantics. So go off and play with Jack and learn Jack if you want to learn what the semantics are that you can replace. If, you know, in the case where we of course we wouldn't have interfaces for things that are just traditional Python. So that's why I'm using this simple walk as a better example to show you how that works rather than circle.jack, because circle.jack is pretty Pythonic. Okay, one thing I'll also point out, I did mention this before, this might be interesting. So we have I guess let me not, I'll just describe it like this. So we have like, if you look at shape here, you'll see like this keyword abs. This is a Jack way of doing it. Just observe it's rendering your Pythonic abs method. And then something like override here, it's generating an override decorator, etc. And so like this gives you a sense as to how the compiler is working. We have a with entry that turns into just the circle, C equals circle. We do this for hygiene. I've described this previously. In general, you want to, this is actually, I would use global C here. So this example is not a very great example here, but in general, we like with entry because you have to be explicit when you have code just lingering in your module, because that code will execute when you import. And that creates bugs that have been very, very hard to find at scale for many, many large scale Python projects. So these are kind of like some tweaks, but anyway, I think you get the point. Of course, we have tests. We have testing infrastructure and features that turns into callouts into Jack test through that machine.py. Okay. All right. So that was a little bit about the runtime library. With that, I wanted to do a quick video, quick and dirty. The key things I want you to understand is how to just get set up so you can run the tests. As you change things, you might want to create tests or run tests. You can look in the code base to see how we build tests. But this might be a good place to kind of tweak and get started, right? You could imagine just adding a simple pass that prints stuff to the screen or changes something and, kind of ratchet up your implementation from there. Awesome. All right, with that, I'll let you guys go. Happy coding, and I'll see you on the next one. Peace.